Welcome to the Chemistry, Biology and Math Revision Hub. Today we're doing the Pearson Edexcel International GCSE Chemistry Paper 2CR for June 2024. Let's begin with the first question. In question 1, this question is about sulfur. The diagram represents the electronic configuration of an atom of sulfur. So, which is this one here? They say which period of the periodic table contains sulfur. To find the number of periods, we count the number of electronic shells. So since there are 3 shells, it means it's in period 3. Then they say what is the charge on the sulfide ion. Because sulfur is in group 6, it's going to gain 2 electrons to become an ion, and the charge will be 2-. Then in part B, when a mixture of sulfur and zinc is heated to a high temperature, a reaction occurs, forming the compound zinc sulfide. Give a reason why the mixture of sulfur and zinc needs heating before a reaction occurs. This is because it has a higher activation energy. Then calculate the relative formula mass of zinc sulfide. Zinc is 65, so we'll get 65 plus 32, giving us 97, and that is the answer. Then question 2, the diagram represents an atom of an element. What is the name of the particle W? Because this is positively charged and W has no charge, this is going to be a neutron. So C is the answer. Then what is the mass number of this atom? The mass number should be the number of protons, which are 4 here, plus the number of neutrons, which are 5, giving us 9. So the answer is C. Then in part B, these are the symbols for the 2 isotopes of lithium. One has mass 6 and the other has mass 7. They say in terms of subatomic particles, give one similarity and one difference between the 2. The similarity is they all have the same number of protons. The difference is they have different numbers of neutrons. Then a sample of lithium contains 7.5% lithium 6 and 92.5% lithium 7. Calculate the relative atomic mass of this sample of lithium. So relative atomic mass should be the percentage of this times mass 6 plus the percentage of that times the mass that, divide everything by 100, giving us 6.925 and rounding off 6.9. In question 3, this question is about magnesium metal and its compounds. The diagram represents the structure of magnesium. Complete the diagram by adding the labels. So we see the magnesium cations and then the delocalized electrons. So magnesium cation, or you could just say cation, and then the delocalized electron. So this should be electron, not electrons. Then explain why magnesium is malleable. It's malleable because when a force is applied, the layers of ions slide past each other and the electrons slide along, holding the structure together. So I say the layers of positive ions can slide over each other. The delocalized electrons allow the structure to remain held together after sliding. In part B, magnesium burns in oxygen to form a solid magnesium oxide. Complete the chemical equation for the reaction by balancing the equation and adding state symbols. So we know magnesium is a solid, this is a gas, and that is a solid. So because oxygens are 2, we need to put a 2 here, and that makes Mg2 as well, so we put a 2 here to balance that. Then give a reason why magnesium is oxidized in this reaction. It's oxidized because we see it gains oxygen. Oxidation is gaining oxygen. Then in part C, a student uses this method to make a solution of magnesium chloride. In step 1, they measure 25 centimeters cubed of dilute hydrochloric acid into a beaker. Step 2, they add magnesium powder a liter at a time. Step 3, they keep adding magnesium powder until it's in excess. And step 4, they remove the excess magnesium powder by filtration. So they've given us the equation for the reaction, and they say give a reason why the student uses magnesium powder rather than magnesium ribbon. This is to increase the surface area in order to allow this reaction to proceed faster or to have a faster rate. Then give a reason why the student adds excess magnesium. If you add excess of this, it means you want this to be completed. So to ensure all the hydrochloric acid reacts, or so that all the acid is neutralized. Then calculate the minimum mass of magnesium needed to react with 25 centimeters cubed of 2 mole per decimeter cubed HCl. So since we have the concentration and volume of HCl, I'll begin with that. Moles of HCl should be this concentration times volume, but in decimeters cubed. That's why I divided by 1000 giving me 0.05 mole. And then I go to the reaction equation. The ratio is 2 to 1, so moles of this should be half the moles of that. So moles of magnesium should be half the moles of the acid, giving us that. And the mass of magnesium should be number of moles times AR, which is 0.025 times 24, giving us 0.60 grams. In question 4, this question is about the manufacture of ethanol by the fermentation of glucose. Fermentation needs to be done in the absence of air. Give 2 other conditions needed for fermentation. We need a warm temperature, about 30 degrees Celsius, and presence of yeast. This is going to give the enzymes that are required for the fermentation process to take place. In part B, explain why fermentation needs to be done in the absence of air. Because an alcohol ethanol is formed, we do not want that ethanol to be oxidized to ethanoic acid. That will give the alcohol a bad taste. So fermentation must be done in absence of air, because the oxygen in the air could convert ethanol to ethanoic acid. Then part C, complete the equation for fermentation. They've given us the glucose part, the ethanol part. The other part should be carbon dioxide. And they're going to be 2. A mixture containing 500 mole of glucose is fermented. A mass of 5750 grams of ethanol is produced. Calculate the percentage yield. Now this is the actual yield, and they want us to find the percentage yield. So I need to first find the theoretical yield. So the theoretical moles of ethanol, these are going to be twice times the moles of the glucose, because the ratio is 1 to 2, so it's going to be 1000 moles. And then the theoretical mass of ethanol should be this number of moles times the MR, giving us 46,000 grams. Percentage yield should be the actual divided by the theoretical times 100, giving us 12.5%. In question 5, sodium sulfate can be prepared by the reaction between sodium hydroxide solution and sodium hydrogen sulfate solution. This is the equation for the reaction. We see that there. There is a sodium hydrogen sulfate solution is acidic. A student adds 25 centimeters cubed of sodium hydroxide solution to a conical flask and adds 2 drops of the indicator. The student does a titration. They say name a piece of apparatus that should be used to add 25 centimeters cubed of sodium hydroxide solution to a conical flask. This is a volumetric pipette, or you can just say pipette. And then describe the method the student should use to find the accurate volume of sodium hydrogen sulfate solution needed to neutralize 25 centimeters cubed of sodium hydroxide. So this means sodium hydroxide is going to be in the conical flask and sodium hydrogen sulfate in the burette. So we need to rinse the burette first with sodium hydrogen sulfate, and then after fill it with a solution. Then, since we already have this in the conical flask, we'll just titrate. So titrate slowly by adding sodium hydrogen sulfate from the burette while swirling the flask continuously. As you approach the end point, add sodium hydrogen sulfate drop by drop until a permanent color change. Then record the final burette reading and calculate the volume added. Repeat the titration until you get at least 2 concordant results and calculate the mean volume from these. In part B, the student repeats the titration without the indicator and forms a solution of sodium sulfate. Describe how the student can obtain pure dry crystals of hydrated sodium sulfate from this solution. So the student has to pour the solution into an evaporating basin and then heat gently to evaporate some of the water until crystallization point is reached. Then you allow the solution to go slowly so all the crystals or more crystals form. You pour off the excess liquid and then dry the crystals using a sheet of filter paper or in a warm oven. In part C, crystals of hydrated sodium sulfate decompose when heated. This is the equation for that decomposition. They say a student uses this apparatus to find the value of X. There is the hydrated sodium sulfate. We see ice and then the water that has been condensed. So the student heats the crystals until the decomposition is complete. The table shows the student's results. We have the mass of the empty test tube, which is that, the mass of the test tube plus the hydrated sample, which is that, meaning the difference between these two will be the mass of the hydrated salt, and then the mass of test tube and sodium sulfate, meaning the difference between these two will be the mass of water. So they say use the results to calculate the value of X. So here I began by getting the mass of the hydrated, which is that minus that, giving us that. We could also do this to get the mass of water and then subtract the water from the original part. But here I did just the anhydrous, so I got 2.84. Then I wrote my equation here. If this is heated, this is how it will occur. And since I've got the mass of the anhydrous, I can get the mass of water by subtracting these two, and I got 3.6. So the number of moles of this should be the mass divided by the MR given, giving us that. And the number of moles of this should be 3.6 the mass divided by 18, giving us that. So the mole ratio is 1 to 10. And therefore, since the ratio is 1 to x, 1 to 10 means x is equal to 10. So that is the answer. In question 6, this question is about electrolysis. The apparatus is used to collect the gas produced when an electric current passes through dilute sulfuric acid. So we see, of course, in this reaction, we have the acid, we have the water. It's going to be hydrogen gas collected from the negative electrode, and then oxygen is going to be collected from the positive electrode. So they can name a suitable material for the inert electrodes. Platinum will be suitable because it's less reactive. Then give a test to show that the gas produced at the positive electrode is oxygen. You will use a glowing splint, and if it relights, then the gas is oxygen. Then give a test to show that the gas produced at the negative electrode is hydrogen. You will use a lead splint, and if it produces a squeaky pop sound, then that is confirmation that is hydrogen gas. Next, give an ionic half equation for the formation of hydrogen at the negative electrode. At the negative electrode, the hydrogen ions approach and they receive electrons to become hydrogen gas. So this is how the equation will be. The oxygen gas in the tube has a volume of that at room temperature and pressure. Calculate the mass in grams of oxygen gas in the tube and give your answer to 3 significant figures. So since we have the volume, number of moles are going to be the volume of gas divided by that value, giving us 0.000742 mole. And then the mass of oxygen is going to be the number of moles times the MR, which is, because in this case we are looking at O2, it's an oxygen molecule, and we get 0.0237 grams. In part B, this apparatus is used to electrolyze a concentrated solution of sodium chloride. Now this is a solution as well, so there is going to be sodium cation, hydrogen cation, chloride anion, and then OH minus, but chlorine in this case is going to be collected at the positive electrode and hydrogen at the negative electrode. This is because sodium is more reactive than hydrogen, so hydrogen will be collected at that electrode. So give a reason why sodium chloride solution conducts electricity. It's an ionic solution, so it contains free ions that can carry charge. The positive ions in the solution are H plus and Na plus. Give a reason why hydrogen forms at the negative electrode rather than sodium. It forms because it's less reactive than sodium. Then a sample of solution is taken from near the negative electrode. The sample is tested with universal indicator. Explain the final color of the universal indicator. So remember, hydrogen ions are going to be removed as hydrogen forms, and that leaves behind OH minus. So the OH minus, this electrode, becomes or forms an alkaline solution, and the universal indicator color is going to turn blue or purple. In question 7, gaseous ethanol is manufactured by reacting ethane with steam. The equation for the reaction is here. They say the pressure on an equilibrium mixture of 3 gases is decreased. All the other conditions are kept the same. Predict the effect of this change on the yield of ethanol at equilibrium, giving a reason for your answer. So if you decrease pressure, then the equilibrium position shifts to the side that has more gaseous molecules. So in this case, it's going to shift to the left. So I say the left side has 2 moles and the right has 1. Decreasing pressure favors the side with more gas molecules. Therefore, the equilibrium position is going to shift to the left, reducing the yield of ethanol. Then predict the effect of adding a catalyst on the yield of ethanol at equilibrium, giving the reason for your answer. A catalyst has no effect because it's going to speed up the forward and backward reaction with the same rate. So I said it does not affect the equilibrium position or yield. It only speeds up the rate of both the forward and the reverse reaction equally. In part B, the equation shows the displayed formulae for the reactants and products. We see them here. They say the table gives the bond energies, which are these here. and they say use the data in the table and the equation show that the enthalpy change delta H is approximately negative 40 kilojoules per mole. So going back to the equation, we have 1 carbon-carbon double bond and 4 carbon hydrogens here. Here we have 2 oxygen hydrogens. The other side we have 1 oxygen hydrogen, and we have 1, 2, 3, 4, 5 carbon hydrogens as well as 1 carbon-carbon. So I'm going to cancel out similar bonds from either side. Since the left has 4 carbon hydrogens and this has 5, we will cancel out and remain with 1. This side has 2 OH and 1 OH, cancel out 1, remain with 1, and then we can work with the rest. So whatever is left is going to be used to calculate the enthalpy change of the bonds broken, or the total enthalpy change. So this is going to be 1 times the carbon-carbon double plus 1 times the oxygen hydrogen, giving us that. Then for the product side, we're going to have 1 times the carbon hydrogen, which is that, plus 1 times the carbon-carbon single bond, which is that, plus 1 times the carbon-oxygen single bond, which is that. And then when we added, I got 1118 kilojoules per mole, here 1077 kilojoules per mole. The enthalpy change should be the summation of bonds broken minus the summation of bonds formed, giving us that minus that, and I got negative 41 kilojoules per mole, which is approximately negative 40 kilojoules per mole. Then explain in terms of bonds broken and bonds formed why this reaction is exothermic. This is because the formation of bonds created or releases more energy than the energy required in the breaking of the bonds. So I say the energy released in forming bonds is greater than the energy absorbed in breaking the bonds, so the reaction is exothermic. Then draw an energy level diagram for the reaction between ethene and steam. They want you to label the enthalpy change. So the reactants were CH2, double bond CH2 plus water, and the product was methanol. So since it's an exothermic reaction, the products are at a lower energy than the reactants. And then I showed the delta H for the reaction as well. The next, ethanoic acid reacts with ethanol to form ester A and water. Complete the equation by adding the displayed formula of ester A. To form this ester, the carboxylic acid part is going to lose OH, so the remaining oxygen here attaches to that carbon, creating this structure here. So this is the ester A. And then give the name of ester A. We name esters by considering the alcohol where it came from and the carboxylic acid. Since it has 2 carbons from the carboxylic acid part, it's going to be ethanoate, and the other side 2 carbons from the alcohol part, it's going to be ethyl. So ethyl ethanoate. So this brings us to the end of question 7, as well as to the end of the whole paper. Thank you for being with us. Do not forget to subscribe. See you in the next video. Bye-bye.